Jai Hind students, today we will be studying about the topic circle. The topic is quite familiar with you all. We have been doing it since class 7. Let's recap the concepts and then move ahead with the same. These are the contents that we would be doing in this chapter: circles and its related terms, angles subtended by a chord at a point, perpendicular from the center to a chord, circle through three given points, equal chords and their distances from the center, angles subtended by an arc of a circle, cyclic quadrilaterals, and then our conclusions. Now let's define circle. The circle is defined as the collection of all the points in a plane which are at a fixed distance from a fixed point in the plane, as you can see in the figure. The line segment joining the center and any point on the circle is also called as the radius of the circle. Now we all know diameter is 2 times the circle. The fixed point is called as the center of the circle. Now if we take 2 points P and Q on a circle, then the line segment PQ is called as a chord of the circle. Next is arc. A piece of a circle between 2 points is called as an arc. The region between an arc and the two radii joining the center to the end points of the arc is called a sector. See that the diagram of the figure, the line segment that is passing through the center is the diameter. The line segment having its 2 points on the center, that is denoted by the green line, is known as the chord. The line which is passing or which is intersecting the circle at 2 points, denoted by the red line, is known as the secant. And the line which touches the circle at exactly 1 point is known as the tangent to a circle, denoted by the purple line in the figure. Now, what are the chords of a circle? As we have already revised, the line segment having its end points at the circle is known as the chord of a circle. A line that joins 2 points on the circumference of a circle is called a chord. A chord passing through the center of the circle is called the diameter. The longest chord of the circle is the diameter. Now, moving ahead, we have segments and sector. Now, a chord divides a circular radii into 2 parts called segments. They are the major segment and the minor segment. As the name indicates, the minor segment is the smaller area and the major segment means the major part of the circle. Sector, the region between the 2 radii of a circle and any of the arcs between them is called a sector. The diameter of a circle divides it into 2 equal segments, or we call them semicircles. Now, angle subtended by a chord at a point. First of all, we take a line segment PQ and a point R not on the line containing PQ. Join PR and QR. Then PRQ is called the angle subtended by the line segment PQ at the point R. In figure circle, the angle POQ is the angle subtended by the chord PQ at the center O. And angle PRQ and PSQ are respectively the angles subtended by PQ at the points R and S, respectively on the major and the minor arcs. Now, this chapter contains various theorems. Now, the theorem 1 of the chapter: equal chords of a circle subtend equal angles at the center. Now in the figure you can see the 2 equal chords AB and CD, and we need to prove that angle AOB is equals to angle COD, and that can be easily proved by using SSS congruence rule. Now theorem 2. Theorem 2 is the converse of theorem 1. It says that if the angles subtended by the chords of a circle at the center are equal, then the chords are equal. Now, there are other certain terms: perpendicular from the center to a chord. Let there be a circle with center O and let AB be one of its chords. Draw a perpendicular bisect perpendicular through O, cutting AB at M. then angle OMA and angle OMB equals to 90 degree, or we can say OM is perpendicular to AB. Thus we conclude that the perpendicular from the center of a circle to a chord bisects the chord. Again, there are two theorems, theorem 10.3 and 10.4 of your NCERT. The perpendicular from the center of a circle to a chord bisects the chord. Like if OB is perpendicular to AC, then AB is equals to BC. And theorem 10.4, the converse of it, it says the line drawn to the center of a circle to bisect a chord is perpendicular to the chord. That is, if AB is equals to BC, then OB is perpendicular to AC. The proof for the same, theorem 10.3, the line through the center of a circle to bisect a chord is perpendicular. And we can prove angle OMA equals to OMB equals to 90 degree by using SSS congruence criteria. Now, equal chords and their distances from the center. Let's first revise the concept. Let AB be a line and P be a point. Since there are infinite number of points on a line, and if we join these points to P, we will get infinitely many line segments such as PL1, PL2, PM, PL3, PL4, etc. Out of these line segments, the perpendicular from P to AB named PM will be the least. Thus, we conclude that the length of the perpendicular from a point to a line is the distance of the line from the point. Now, again two theorems from the chapter. Theorem 10.6 says that equal chords of a circle are equidistant from the center of a circle. And the converse of the same, chords equidistant from the center of a circle are equal in length. More clear from the figure, please look at the figure. Let AB and CD, let AB and PQ be the two equal chords, then their distances from the center will also be equal. Here the distance OM will be equal to ON, and vice versa. If the distance OM is equal to the distance ON, then the chords AB will be equal to the chord PQ. Theorem 4. Equal chords of a circle are equidistant from the center. We just now did the proof, and here it is clear from the figure as well. Now, a very important theorem of this chapter, the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Here is the proof. Let us see. In this proof, we draw three figures. The first figure you can see where PQ is a minor arc. Second figure you can see the PQ is a semicircle, and in the third figure we can see that PQ is a major arc. Now here we need to prove that angle POQ, which is a central angle made by the arc PQ, is twice of the angle made by the base arc PQ. That is, the angle POQ should be twice of angle PAQ. Now how can we prove this? The proof is quite easy if you go through it. Let us draw AB. Now if we see at triangle AOP, then angle OAP is equal to angle OPA. Why? Because of the isosceles property of the triangles. If two sides are equal, then the angles opposite to them are equal. Now, if we look at angle POB, it seems to be the exterior angle for the triangle AOP. So, angle POB is equals to twice of angle PAO. Similarly, angle QOB is twice the angle QAO. And adding these two will get angle POQ twice of angle PAQ. Now, when it is a case of semicircle, you can see angle PBQ is a straight line, or it's an angle of 180 degree. That indicates that angle PAQ would be of 90 degree. And when you can see the case of a major arc, then the reflex of the central angle POQ is twice of the angle made by the arc at any other point on the circle. Thus we conclude certain results that Angle in a semicircle is a right angle. As it is clear from the figure, AOB is the chord or the diameter, and the angle at the center is 180 degree. Now all the angles that are aligned in the semicircle, say AQP, APB and ARB, would be of 90 degree. Thus we have concluded that angle in a semicircle is a right angle. Theorem 10. Next theorem, angles in the same segment of a circle are equal. Now look at the given figure. PQ is an arc and the angles PAQ and PCQ are made in the same segment, and these angles are equal. Now moving to the last concept of the chapter, that is the cyclic quadrilaterals. A quadrilateral ABCD is called cyclic if all the four vertices of it lie on a circle. If we observe these cyclic quadrilaterals, we find that angle A plus angle C is equals to 180 degree, and also angle B plus angle D is equals to 180 degree. We conclude that the sum of the either pair of opposite angles of a cyclic quadrilateral is 180 degree, and so the converse of this is also true, that if the sum of a pair of opposite angles of a quadrilateral is 180 degree, then the quadrilateral is cyclic. And you can try the questions based on the various concepts, and we'll discuss them in future. Thank you.